Hi, I'm Charlie with Precision Matthews, and today we're going to reach into my frequently asked questions folder to cover some lathe work holding basics. A lot of customers are upgrading from an older machine that may have a screw-on type lathe chuck or a bolt-on backing plate to mount the chuck to the lathe spindle. Someone like that may not be familiar with the modern D1 camlock style chuck mounting interface. In this video, we're going to go over some of the basics of using this style of chuck mount. Let's get started. First things first, let's get this chuck off of our 1440 TLV lathe so that we can see what's going on back there. Remember that you always want something to protect the ways, because chucks are heavy and often covered in oil, and it only takes one time to drop it and have a big gouge in your ways that you have to look at every time you run the machine. I have this scrap of OSB that I grabbed from our crate making area, but you can get fancy if you want. Often people will make a custom cradle out of Delrin, HDPE, or some other easily machinable plastic. I haven't done this, but it's always 3 items down from the top on my shop to-do list. As you can see, you just go around the circumference of the spindle, loosening all the cam locks, then give the chuck a good whack with your dead blow mallet to break the tension of the taper, and you're free and clear. We'll concern ourselves with 3 sizes of D1 style chuck backing plate: D1-4, D1-5, and D1-6. There are sizes smaller than that for very small lathes, and larger than that for very large lathes, but these are the 3 most common sizes, and the 3 that we sell. If you know what standard your lathe is, you can be sure that any work holding you order off the shelf in that size will work with your lathe. One thing to note: the number of cam studs does not correspond with the number in the standard. That is, the D1-4 standard has 3 studs, D1-5 has 6 studs, and D1-6 has also 6 studs, but they're a different size and hole pattern from the D1-5 6 studs. As far as I can tell, the second number in the D1 standard does not correspond to any dimension at all. Let me know in the comments if I'm wrong about that. No matter the size, at the heart of this system is some number of studs that mate into bores in the face of the spindle. Then a cam in the spindle is turned to draw the stud in and seat the chuck on the taper. Note the presence of a socket head cap screw, which does the important job of keeping the stud from rotating when it's engaged with the cam. Note also the line etched around the outside of the stud, because we'll need that in a second. We just screw each stud into the back of the chuck until that etched line is flush with the surface of the backing plate. That'll be a good starting point to get us close on length of the stud and how it mates with the cam and the spindle. If there's one thing I want you to take away from this, it's the following. Put the socket head cap screw in as soon as you get the stud screwed to the desired depth. Don't walk away and do something else. Don't try the fitment of the chuck on the spindle and figure you'll put the cap screws in once you're sure you don't need to adjust the studs. Just put the cap screw in. It takes 5 seconds. You can take it out again if you need to adjust the stud length. If you put the chuck on without the cap screw in and the stud rotates and binds with the cam, you're stuck. Like very stuck. Like some component of this system needs to be destroyed with a drill to get the chuck off stuck. The areas around the cams in the spindle will have marks at 12 o'clock, 3 o'clock, and 6 o'clock, and a corresponding hash mark on the cam itself that references these marks. To prepare to mount the chuck, you want that hash mark to be in the 12 o'clock position on all cams. That's the fully open position. Again, mount your high precision machinist OSB to protect the ways and get the chuck in place. Get the studs into the bores and go around cranking on all the cams. I like to go around once, just lightly snugging them, then go around again and crank them down more. I don't know if this does anything, but it makes me feel like I'm being thorough. Maybe at the end of my life, seconds before the lights go out and I shuffle off this mortal coil, I'll have the realization that I only needed to go around the one time all those times. That would be the machinist version of getting to the afterlife and realizing you picked the wrong religion this whole time. Unrelated, I guess I could have put the headstock in neutral to make this easier. That's probably what a truly righteous man would have done. Now go around and make sure that the hash mark on each cam that was at the 12 o'clock position is now somewhere between 3 and 6 o'clock. If it doesn't go past 3 o'clock, shown here, your stud is a little too short and you need to take the chuck off, back that stud out one turn, and remount the chuck. If it goes past 6 o'clock, shown here, your stud is a little too long and you need to take the chuck off, screw the stud clockwise one turn, and try again. Once all the cams land somewhere between 3 and 6 o'clock, you're ready to go. So there you have it. If you didn't know about the D1 camlock style chuck mount, now you know. It's a simple design, easy to work with, and foolproof for all but the most determined fools. As always, if you have any questions, drop them in the comments or contact our tech department to cover any of these subjects more in depth. Until next time, thanks for watching.